Hello, this is Andrew Wheatley, and this is my physics demonstration. So first thing we're going to look at is a sphere-sphere collision. So I'm just going to reset the simulation here by pressing R. And you can see the red and blue ball collide together. So we'll also look at some sphere environment collisions. So if you press 2, that takes us to the observation deck, and we can watch the balls collide with the environment. You press 1, you can watch the user controlled ball go down the ramp. And the spheres also react with a moving object. You notice it disappeared. There's a timer on there so that things don't just lie around for a little bit, for too long. In the code, you'll see in the collision manager CVP do collision response that objects, all the triangles that the object is colliding with are taken into account, and we look at all the normals and then select the appropriate normals to react with. As well, you can see the purple balls colliding with the blue triangle there. That is actually AABB collision, not OBB. I've just created an AABB box and do testing that way. And then if there's a triangle collision, we do the collision response. There are about 20 spheres in this project. You see my user-controlled sphere bouncing down the stairs. You can control the sphere with WASD. And when it's making a collision, you can also jump. Just give it a little acceleration. There we go. If an object goes off the level, it gets reset to its initial position. And all of this is in a user readable file. So for objects, you got the file name, position, some lighting, material, information, shininess. This is the initial acceleration in XYZ. This tells the program that it's a sphere. It's non-static. It means that non-static means it makes collisions. And then this is kind of like the elasticity. So 0 is inelastic and 1 is totally elastic. So the red and the blue ball that you saw at the beginning have an initial acceleration of 50,000, just so they get enough velocity. If you look down here, we have a mover, those 2 green blocks. Same idea, except we give them an initial target, a first target and a second target position, and the speed at which they move. And then we have our lights. And that's about it. Thanks.